Hello everyone. Welcome to the session on surface areas and volumes. In this session, we will learn about the method of finding the surface areas and volumes of different solid figures and the relation in their surface areas and volumes if exists. So first let us know the solid figures are divided into the solid figures based on their edges. They have straight edges and curved edges. So straight edges we have cube and cuboid are said to have straight edges, and curved edges, one is cone, the other one is cylinder, and the next one is a sphere. So we are going to learn about these solid figures, their surface areas and volumes. So let us start with the first solid figure, that is a cube, which is the most familiar one. So let us take the figure of a cube, and we know that a cube is formed by 6 faces, and those faces are squares. So we can say that it is formed by 6 square faces, and it has 8 vertices. So these form the vertices. At the top we have 4 and at the bottom we have 4. And it has 12 edges. So on the top we have 4 and at the bottom we have 4. And here we take these 2 because these 2 are not counted, and this side 2. So total we have 12 edges. So let us see the 2D figure, that is when I spread this net, that is when I take the net of a cube, it appears in this manner. So to calculate the surface area, so this visualization helps us to remember the surface area formula. So we know that this to find out the surface area of a cube, which is given by 6 squares. So area of each square is a square. So it is given by 6a square units. And if we want to calculate the volume, which is given by length into breadth into height, and we know that in each case it is a units, so which is a cube cubic units. So that gives us the volume of the cube formula. Now let us see the cuboid. So cube and cuboid are similar. The only difference is in the measurements of their sides. Let us take the cuboid. So this is a 3D view of a cuboid. And if I take the net of a cuboid, so you can get like this. So which helps us to understand that it has 3 types of rectangles, and all are rectangles obviously. So 3 pairs of rectangles it has. So let us take that it has to calculate the surface area. Let us take it has 2 rectangles having measurements as L and B, plus 2 rectangles having as B and H, and 2 rectangles having as L and H. So that gives us the formula 2 times of LB plus BH plus HL. So this forms the surface area of a cuboid. So how we will find the volume of a cuboid then? So we know that it is LBH, and here LBH are different. So the formula remains the same, L into B into H cubic units. So this is how we calculate the volume and surface area of a cuboid. Now let us take a cylinder. A cylinder, as we discussed in the beginning, it is having a curved edges. So let us take a cylinder and its net. So if you see the net, we can easily make out that it is formed by one rectangle and two circles. So here it has two kinds of surface area. One is a curved surface area. So the curved surface area is this part area, only the surfaces, that is the top and the bottom are not included in the curved surface area. If we consider a total surface area, for example, if I want to paint the cylinder completely, then I have to paint all the surface areas, hence we call it as a total surface area. Lateral surface area in the sense, for example, if I take a piece of paper which is in the rectangle, and just if I paste these edges, then I get a cylinder, that is hollow cylinder. So the area of the paper is nothing but the curved surface area of a cylinder. So let us take the formula. Curved surface area of a cylinder is equal to, that is length into breadth, as it is in the form of a rectangle. So what is L here? So L is nothing but, when I roll it, it forms the circumference of a circle. So hence I take it as 2 pi r, and breadth is nothing but it forms the height of a cylinder when it is rolled. So it is 2 pi r h square units. And if I want to calculate the total surface area of a cylinder, then the lateral surface area, which is given by 2 pi r h, or we call it as a curved surface area, plus two circles. The area of two circles is given by 2 pi r square. So hence if I take 2 pi r common, I can just give it as h plus r. So this forms the total surface area of a cylinder. Now next figure, let us go with the cone or sphere. Both are left for us. So first let us take a sphere. A sphere is a 3D figure, as we know, but can I draw a sphere on a plain sheet of paper? No. If I represent a circle or a sphere, they look the same. Only it depends upon the way I draw it. Right, then how do we calculate the total surface area and the curved surface area of a sphere? And here we have to remember one great mathematician, Archimedes, who gave the relation between the cylinder and the surface area of a sphere. That is, if I take a cylinder and if I take a sphere inside it, that is, which has the height same, that is the diameter of a sphere is equal to the height of a cylinder. Here the measurements, here also it's the same. So in that case, he said that lateral surface area of cylinder is equal to surface area of sphere. So lateral surface area of a cylinder, we have seen that it is given by 2 pi r h. And here h is nothing but the diameter, which is given by 2r. So in that case, we get it as 4 pi r square. That is 4 times the area of a circle. 4 times the area of a circle, you can say. That means, to visualize, if I get the circular pieces, 4 circular pieces having the same radius, then I can just cover this sphere completely. So that is the meaning of it. And let us understand a few points here related to the sphere. Sphere, when I take a complete sphere and cut it, So what will I get? I'll get hemisphere. That is half of a sphere. We call it as a hemisphere. And this hemisphere is of two types. One is hollow. If I take a tennis ball inside, if I just cut it, inside will be hollow. And if I just take an orange or a lemon and cut into two halves, then I have a solid sphere. Then how do I find the surface area of the hollow sphere and the solid sphere? In this case, we know that surface area of a sphere is given by 4 pi r square. Hemisphere is obviously, hemisphere means half cut into two halves, so which is 2 pi r square. This is applicable in the case of a tennis ball. But what about the solid hemisphere? So this part is also added. So if I want to paint this solid hemisphere, then this part I have to paint completely, and this part, that is area of a circle. So 2 pi r square plus pi r square gives us 3 pi r square. So total surface area will be 4 pi r square. Hemisphere, that is a hollow surface area, will be 2 pi r square, and solid surface area will be 3 pi r square. So this is about the hemisphere and sphere. Let us take one example to understand its application in our daily life. So if I just say that to find out the leather needed to make a football. Okay, here I want to make a football, and I want you to calculate and tell what is the leather, how much leather do I need to buy from the market to make the football of diameter 22 centimeters. So in this case, to find the surface area, I need only one parameter, that is I need radius. Right, I know the surface area of a sphere. Formula is 4 pi r squared, which is 4 into, let us take pi as 3.14 into, radius is half of the diameter, so it's 11 square. So when we calculate, we'll get it as 1519.76 square centimeters. So this is the quantity of leather in square units needed to make the football. So this is how we apply the formula in calculating the surface area. Now let us go to the next one, that is a cone. So cone, specifically in our syllabus, we have the right circular cone. So what is a right circular cone? Right circular in the sense, if we take a circle and cut it exactly one right angle part from it. That is, if I take a circle and exactly I cut this shaded part and attach these edges, then I get a right circular cone. And in that case, we have two areas again. One is lateral surface area of a cone, and that is a lateral surface area is also called as a curved surface area of the cone, and the total surface area of a cone. So what is the lateral surface area? Let us just take this to little left side, then yeah. Now if I want to calculate the curved surface area of a cone, CSA of a cone, I know that it is equal to pi r L. How do we get this pi r L, which is in the shape of a length? This is a slanting, this forms a, what is the length we consider in the cone? So this is called as a slanting length, and this is the radius we have. So if I want to just paint this only the lateral surface area, then I have to multiply pi r L. And if I want to calculate the total surface area, then I have to add the base area, which is a circle, which gives us total surface area is equal to pi RL plus pi r square. Common if I take as pi r, it will be L plus R. So this formula gives us the total surface area of a cone. To understand more about its application in the word problems, let us understand few relations before that. What is the relation between the cone and sphere? That is the relation between their volumes, we will see. So let us take one example. Yeah, this is a cylinder and a cone. If I take a cylinder and cone having the same radius and height as the same, then I need to, what is the relation between their volumes? So volume of a cylinder is 3 times the volume of a cone. So volume of a cylinder is equal to 3 times the volume of cone. So what is the volume of the cone? So we know that volume of a cylinder formula is pi r square h is equal to 3 times the volume of cone. So how do I get the volume of the cone, which is equal to 1 by 3 pi r square h. So this is the formula we use to find the volume of the cone. I hope you have understood the basic concepts of the surface areas and volumes of different solid figures. Thank you.